Hi, and welcome to this quick tool review. This time around we have some items from small to really big that have added a lot to my shop, but we're going to start with the smallest of items, but essential for a shop as small as mine, like this press. It has to be mobile because it's pushed up against the side to give me room to walk until I actually need it. Then I have to roll it out so that I can use it. Ultimately, I'd like to put this guy on some sort of caster that would allow it to also be fixed in place until I needed to move it so I could just roll it out of the way. That would be really handy because this thing weighs about 1,800 pounds, 1,700 pounds, something like that. Very hard to move. So we've all seen the common caster, which has locking wheels, but I'm sure anyone who's dealt with swiveling casters that lock, you lock the wheels, it'll still tend to rotate in place a bit. And if you want to set leveling, these are not ideal. So I have two solutions that I ran across this week that I'm going to try out. First set of casters are for items like the bandsaw that don't move very often but want to move occasionally, and you still want to be able to level them and fix them in place. I ran across these guys on both eBay and Amazon. I purchased these on Amazon, and I will provide a link below. So these guys, this set is good for 2,200 pounds for the four, which is absolutely amazing. Looks like cast aluminum for the body here, which makes them pretty darn light. And then if you want to drop the foot, which just sits normally, it's a nice high durometer rubber, sits normally just above the wheel, you can either pull the foot up or drop it down to lock it in place. They come in two styles. They come with a standard square bolt-on flange, and this is the threaded flange. The threaded flange kit comes with set screws. These are 1/2" 13 set screws that let you thread in one side with an Allen. They're basically long set screws, and then thread this guy on normally and lock it in place. I assume you'd want to use some Loctite or a lock nut that's also provided, which is pretty awesome. So this set, pretty amazing find. They were fairly inexpensive too. You're not going to believe this, but this set was only $80 for four. That makes them $20 a caster. The casters themselves are hard plastic, so if you're doing a ton of moving, these probably won't have a tremendously decent lifespan. Although, the way they designed them, it looks like they have a square hub and a round shaft that's slightly larger with just these screws holding them in, and you could pop this out and replace the wheel if need be. So that's pretty handy, if you could find the wheel. But the hard plastic, not the best I've ever seen, but for the price, this is pretty amazing, especially if you're not rolling it often. If you're only rolling once in a while, these will probably last a lifetime of the product, or project. Tool in my case. This next set of casters doesn't have the weight capability, only 660 pounds per set for this size, and it doesn't have leveling ability like the other ones. The other one will allow you to level, adjust the level on something. This one either is fixed in place on feet or rolling on casters. So this is a slightly different version. This set was only $58.99 on Amazon, and I'll provide links to these below if you're interested in going and finding them. They take some standard casters that have the stud on the end, and they thread into this piece right here. And what that does is you have a leg of whatever it is that you're mounting this to, and it extends down here about this much right here. And what happens is when this part is up, the caster is not engaged and you're sitting on the leg. When you step down on this using your body weight, which makes it easy to lift a fairly heavy item, the caster is engaged and it raises the foot just slightly above the bottom level of the wheel, which is pretty awesome. And you can roll your item around. When you're done, you flip it up. However, you don't have any adjusting ability built into this. However, if you wanted some, the foot section that sticks down here, you could put a threaded foot on there, and then you'd have all the flexibility you want. The downside of this set compared to the previous one is that you require a separate foot or just the leg of whatever it is you're attaching it to, and the weight capacity is significantly less. However, this is much easier to move because the previous set, every time you want to move these around, you have to dial all of these feet up. and that could be a big pain in the butt. So this is for seldom moved items. This is more for more often moved items. I thought they were pretty neat. That's why I'm sharing with you, because I was looking for a solution and I ran across these lately, and very creative. All right, let's move on to some bigger items. All right, next up we have a set that I got at an amazing price. And a little bit of history, I've been looking to buy one of these for a very long time. They typically go for used somewhere over $1,000, something like $1,100, $1,200. Occasionally you see them dip just below $1,000, but not much else. I was gonna make my own version of this tool using this compound I got on eBay. It's a brand new compound for a 14-inch throw lathe. And you wanna see something funny, I should show you the comparison of this compound for a 14-inch lathe and my 14-inch lathe compound. Let's go take a look. All right, so here's the compound, 14-inch lathe. This is a 14-inch lathe. Look at the comparison of my compound. It's like 1/4 the volume of this thing. That is crazy. This must have been a super light-duty 14-inch lathe. In any case, I was all prepped to make this into the tool I needed, and lo and behold, like 1 week after I buy this part, this guy goes for an amazingly low price. So here's what I got for the deal. I'm very thankful they sold it for so little. I still can't believe they did. It's a Holdridge Model 4D radii cutter set. It looks fairly complete too. It's used, but in really good shape, and lets you cut ball shapes or concave shapes. So this would be a convex or ball shape right here. And when you go to this side, it cuts a convex shape, concave shape. Lets you do a pocket, so you can do pockets and balls that fit the pockets. I've never used one before, but I've been very excited to try one, so I've been looking forward to this for a long time. I was going to make my own version using this compound, but this was an amazing find, literally 1 week after I got the compound, as I mentioned. It also lets you just rotate between two very specific angles if you want. You put this attachment on top, it fits there, and lets you control the amount of angle you're throwing. And you've got two pieces for the inside here. This is for smaller diameter balls and pockets, and this is for the larger right there. And it comes with 3 of these guys. I assume they're for really small, but I'm not in straight spindle. Yeah, this must be for very small concave pockets, I'm guessing. I'm not entirely sure. They also hold different diameter cutters. That looks like 1/4 inch, and this looks like about 3/8, and this guy looks like 1/2 inch. Other than that, and because they stick out further, this would be a slightly different minimum radius. But I'm not quite sure. I got to read the instructions because I've never used one of these before, but I'm really excited to try it. And they show methods for getting a specific diameter using a micrometer off the face of these. Whoa, they're ground. Okay, so you set the micrometer to get your cutter depth exact, and yeah, both the small and the large have ground faces. That was a nice addition. That's very good thinking. Still need to make a plate to fit my compound on my lathe, but I look forward to using this, and hopefully it'll show up in a project soon. Oh, one look in the brochure that came with this guy, that lets you see the kind of things you can turn. Oh look, they made an entire cup on a lathe. That must have been quite a project. I can imagine this would ring like crazy as you're doing it. But they do all kinds of interesting projects. If you don't want to use a radius form cutter, you can use the radius tool and cut a round form like I did on, I don't know where the part went now, a little clanger I made. Looks like you could do all kinds of neat stuff with this thing. So again, I'm looking forward to using it, and hope it'll show up in a project soon. They also have a motorized add-on if you want. And the motorized add-on will rotate back and forth for you. I've seen these for sale too. They usually go for almost $1,000 all by themselves. So this is not an inexpensive piece of kit. Finally, we reached the last item I got this week. And this is kind of a big item. It's another tool I never had a whole lot of need for. I've had some very specific uses where it would have been amazingly handy, but never enough to warrant the price. New, like the big brands like Hugin or Milwaukee. They cost well over $1,000 for one of these guys, and I didn't use it enough to warrant it. I'm one of those guys that if I use a tool all the time, like the ones I have work, I buy top of the line tools because they help you make sure that the only limiting factor in your job is you, not your tools. So I tend to buy those for work if I'm using them every day, but tools I rarely use, I'm willing to take a risk. This risk I sort of took for you guys and me just to see if the quality was worth a spit, because the price of this is less than a quarter of the price of the main brand ones, maybe even a fifth in some cases. So let's take a look. I've already taken the foam out of the top of this guy. So I popped the foam off this guy, and it's a magnetic drill press, a couple hundred, let's see, what is this one? 1,550 watts motor, supposedly, you know, magically rated. And even the set even comes with some annular cutters, which is really weird that they'd even be able to pull that off. I'm not quite sure what this bit's for, and I don't see any instructions in here. There's a rope. I don't know if maybe that's to lift it. This thing's pretty darn heavy. Let's get this guy unpackaged so we can take a look at it. All right, so here's first perception. This thing is pretty rough in many ways. So the dovetails are actually pieces of extruded steel, not ground at all. And the action of this is workable, but as you can see, I struggle a little bit to turn it. There is a lot of friction. Now you could probably adjust the gibs on the other side, which the gibs I think are this whole plate. They've got leveling. They don't have separate gibs on this guy. I think it's just this whole piece moves. You loosen these screws and then adjust that. It will stay in place like this, but we'll check the magnetic field in a second. It looks like the drive shaft is Morse taper, and so you could pop the whole drive shaft out and replace it with something else if you wanted. They gave you this Morse taper removing key that is just a stamped piece of metal, and you know how soft this is. It's going to gall immediately in hardened metal. If you try and tap this in more than a couple times, it's probably not going to work great. It's got the locating pin for all the annular cutters, which it came with over here. It's got a coolant bottle with a really cheeseball mounting system that is razor sharp and not even square cut. I'm not even sure where that mounts. There's no instructions that come with this guy. However, I don't think I'll ever want to use this as is, because every part of this is razor sharp all the way around, because it's just stamped strapping material. It's got a little pin valve on the bottom. Anyways, I think that thing's garbage. The coolant goes in here while it's moving, and it's kept in place just by this little pin that goes up in here and stops this from rotating too much. This is fairly stiff, which makes it feel like it's on rubber O-rings, which means that's going to be a replaceable part in the probably not too distant future. One thing it didn't come with that I purchased extra was a drill chuck, because I wanted to use it for smaller drills as well, although this drill bit does not go, chuck does not go terribly small. Let's see, they're saying it's 3mm to 16mm, so it'll do 1/8 inch, about 1/8 of an inch and up, not much smaller. So we got that to fit in here. However, I could have taken advantage of the Morse taper and just used that. And if you don't want to use the coolant, which, you know, if you want to do deep cutting in steel, you probably do want the coolant. You could probably just remove this part and run it without. The controls, very, very thin aluminum, and the protective coating on it. No, that's not the protective coating. I thought that was that protective wrap over the aluminum, but it's not. It's just weird blue paint in the corners. Very, very flimsy feeling. And you know, I'm only going to use this once in a while, so hopefully it'll work. We're going to give it a shot over on a place where I screwed up. I'll just show you where I want to test this guy out. So originally, I drilled this 1/4 inch pin here to locate this guy at 0 so I could do angles and come back to 0 quickly. And I drilled and reamed it. However, for whatever reason, I had this clamped down tight, drilled through with my hand drill, and the darn thing bound up a couple times. So it didn't go in quite straight, because I broke one drill bit and had a hard time getting it out. So I'm really not sure what happened there, but I want to drill this slightly oversized using an end mill since the hole's mostly drilled out, provided that drill chuck will fit in here. That's going to be a whole nother thing. So I want to drill it out slightly larger and then ream it straight up and down. And we're going to use the magnetic drill for that. And I've had several other uses because I wanted to make some changes, put some threaded holes on here. And to take this piece off and lift it would throw my back out. So the magnetic drill would let me drill, albeit not as accurate as putting it on the lathe, but I should be able to get reasonably accurate if I lay out the lines carefully. Oh, before we head over, another observation I noticed, a couple things. One, this is only a single speed, supposedly ideally 600 RPM, although it doesn't come with a manual, but that's what the site says. 600 RPM. Some of the better drills come with 2 speeds, so they go even slower when you're doing the really big annular cutters. Also, I gotta say, I'm not sure, but the inside is really, if it's ground, it does not feel great. Let's see. Yeah, there's a bit of slop there. A lot of these annular cutter arbors don't have hardly any space at all. I think they're relying on catching on the flats, but yeah, that's not really a positive comment either. About this thing. So it is cheap in every way. If it does what I need it to do, I'm okay with it. But I'm just warning any of you, if you're planning on using this, like on job sites, don't go cheap for this so far. We'll check out the motor next. It is a brushed motor, as you can see here. And I gotta say, that's impressive. The top of the motor housing is cast aluminum. It's solid. I didn't expect that, which makes this thing, of course, very, very heavy to move around. This whole thing is cast aluminum, this whole, with multiple handle spots. So that's nice. Yeah, we'll see if we can even fit this close enough to where I want to drill. This is normally designed to drill over on solid plate stock, you know, like I-beams and things like that. So the magnet does stick out a little bit far forward here, which means you can't get too close to what you can't drill deep into something with a ledge, because this will run into it, which might be a problem for me. We'll just have to see. All right, so here's the application I wanted to use it in, and you can see that the rack and pinion is not great. The magnet, however, is incredibly strong. And we're going to see if we can adjust the dovetails to be a little bit better, because there are screws on this side to push that piece that's the dovetail on this side to push it in, but there's no ground surfaces. There's no machine surfaces. It looks like this is just, I don't see machining marks. It kind of looks like it's just cast, and they just press the pieces together. That's totally cheesy. There's quite a bit of run out on the drill chuck, which didn't come with it, but there's also a lot of run out on the shaft itself. Here's the run out of the motor shaft. It's a Morse taper, but you can see the whole thing wiggling around. It actually looks like it looks like the run out is on the order of 2 or 3 thousandths, which is, I guess, not horrible for an inexpensive item, but it's not very impressive either. And then, you know, if you're out by a couple thousandths here, and then you have a big bit sticking down another few inches, you know, rotating a couple thousandths precessing here, down here, would be like 5/10 thousandths, you know, a slight angle off, and the farther away you get, the bigger the offset is. So, yeah, that's not great. This is only designed for up to 2-inch depth of cut, 2-inch depth of cut, 2-inch diameter tools, cutters, annular cutters. So it's designed for power and really moderate accuracy, nothing precision at all. So if that's what you're looking for, this is definitely not the item for you. The magnet has a lot of hysteresis in it. So when you turn the magnet off, it still sticks pretty good until you break it free. So that's also a problem. It would be nice if they had a way to reverse polarity on the magnet just for a brief burst, like a push button, that you could demagnetize the cast iron that is put in. All right, let's try and drill something. All righty, So we're going to try and drill this out to 5/16 from 1/4. And I've got a 1/4 inch, 5/16 end mill here, but I'm worried that it's going to break it with the precession. A drill bit just will follow the hole, and I might not be able to get a straight hole. So I'm going to take this very slowly. So it drilled okay, but the amount of motion at the bottom is way too much to get any kind of accurate hole. If you need an accurate hole, this is not going to work. Just a heads up. I decided to go for 3/8, and this is a drill bit. And the vibration you can definitely feel in the cut. So this is drilled one size under 3/8, and then I'm going to try a reamer, although I don't have high hopes for the reamer because the amount of motion at the end of this is significant, and that's not good for the reamer or anything else for that matter. You want to see what I mean by precession? Look at how far out it is down at the end of the reamer. So although it was never intended for it, you can't just make it work for precision work. It is definitely no good for that. Not enough quality in the bearings and the shaft and everything else. But, you know, I didn't expect amazing things because this was only 300 and something bucks. Despite the incredible amount of bouncing around that reamer was doing at the end, it made a very, very snug fit. Heard it pop there. So that's good. So I'm going to make something with a knob on it that I can push in here and get these parts to align. There's almost no wiggle there. So I'm very impressed at that fit. I didn't think it was going to be that good. So that'll help me align this. So it served its purpose as far as that's concerned. But if you want to use this guy on anything more than the coarsest of projects like, you know, building construction, that sort of thing, I think it's going to need a lot of work before you get there. I will try and play with the Gibbs and see if I can get them better. But if you're going to use this in a business setting, I would not recommend this at all. If you're going to use this at home just occasionally for rough holes, it's probably adequate. I heard the motor bogged down a bit just cutting that 3/8 inch hole. And I opted for 3/8 over the 5/16 because I wanted to make sure I cleared the edge of the hole because the last one went in an angle and it required 3/8 to get there because it was unfortunately at quite a tilt. Before we leave this guy, I want to take a closer look at some of the issues with it and see if maybe they're addressable. So for starters, when I reach inside this bore here, the part that is ground for 3/4 inch or approximately 3/4 inch is only the outside, I don't know, maybe 1/4 inch or less. That would be 6 millimeters or less. That's ridiculous. That means the whole bearing surface for the ground surface to mate on is only about this big. And so the rest of this is not actually meeting any material, which is why, among other things, this thing slops around so much. Also, the bore of the hole is larger than the cutter. And what happens when you're tightening from one side, in a 3-jaw chuck like this style, when you tighten, even if there was a bit of a gap, you're tightening from 3 sides, which is going to tend to want to automatically center the bit. But when you're tightening from one side like this, and you push the cutter against the other side of the bore, you're shifting it off center automatically, which is a horrible design, which means this needs to be ground pretty accurately. Let's just measure and see what we get for those values. Let's start with measuring an inexpensive annular cutter. Here it measures at 0.748 from widest point to widest point, and it's consistent across the gap, maybe 5/10 here. As a second sample, here's a Hugin annular cutter, and it measures 0.749 as the high spot. Let's take a look at the inside bore. So it's 751, so that's going to leave 2000s, but the fact that it's only grabbing on a tiny area is not helpful. And when these things push in, opposite them is a gap. I think it's probably going to be fairly easy to replace because this looks like a Morse taper too. Let's see if we can pop this off. All right, let's see if this guy removes. I was going to take this over and sand it off and make it smooth, which would be better by a lot because all the little parts that are sticking up here are grabbing on the side of the aluminum casting. But let's just use it as delivered. So let's see, the flat side is this side. Okay, that's working like a charm, isn't it? No. All right. So that didn't work very well. And like I suspected, it was wearing down the material the first time riding on the top part of the stamping here. Here's a somewhat better made tool. Let's see if we can pop it out with this one. Wow, they pressed that in there within an inch of its life. So it is a Morse taper too. And I looked on eBay and you can actually buy one of these. Now, one of the things I'd like to check here is how accurately they ground the bore in this guy. There is a really large exit ball bearing from here, which is nice. That seems like a good design. Let's see what we can do about checking the run out just in the Morse taper bore. Before we head over there, maybe you can see what I'm talking about. So the ground section is just at the very edge. I think that's to allow coolant to go around the outside of the cutter a little bit. I don't see the advantage to that particularly. All right, so the bore's out by less than 1/1000. For such an inexpensive device, I think that's pretty darn good. Something else I just noticed is actually on right now. That looks like the magnet's on, right? Actually, that's magnet on. These indications are wrong. I wonder if I open this up, if this is a single pole double throw switch, and I could just flip the wire to the other side so that that would be on and that would be off. Although you probably want off to be down, so in case you drop something on it, it would turn it off. I don't know, but it is backwards. Well, let's see if I can reverse the polarity. If that's a simple on-off switch, then they just got the silk screen wrong, which is hilarious. It might explain a lot of things about this particular drill motor. I have removed the handles here just for ease of access. Also, it is unplugged. Oh, look at that. There's your full way bridge. Oh, look at that. Yes, I could just move this to the other side and make that right. So we're gonna do that because that's just nutty. And let me pop this over here. Yeah, so I can just move these two wires here to the other side, and that will make this guy go on when the universal on symbol is down. And if I wanted, I could spin this guy around. It's just held in here with pressure too, so I could do that as well. Now let's move these real quick. Not that it's any surprise, but there is no heat shrink inside here like you would normally expect to find. I mean, with all metal case and whatnot. They at least do ground the whole outside of this, so if one of these wires were to touch the metal plate or the case, they would just trip the breaker or blow this fuse right here. I think what this could really use would be a complete rewiring. Now, when this guy goes on, the magnet will follow. So inside here, this is a pretty simple device. Inside here, you have just your AC coming in. You have power going to the drill motor that goes to this switch here. And this switch is 16 amp 250, 20 amp 125. So hopefully it'll survive the on-off of a motor. You do have inductive kickback that tends to arc across contacts of switches, so if you turn on big motors, you can easily damage switches. On top of that, you have the electromagnet. The electromagnet is on the output of this switch, and it goes through just a full wave bridge here. You can see the full wave bridge rectifier right down here. Inexpensively done, but effective. And it looks like this magnet could have been wired, well, 120 or 220. They put it, no, it's in series, so I'm figuring, yeah, that's interesting. It must be a different magnet for 220 because they put it in series, which you would think would be for the larger voltage, but I don't think it is, because I'm running this off 110, so that's really odd. What does that make it, 110 or nothing? There are two, maybe they never intended that. There are two coils in this guy. Although you think, again, you could run the coils either in series or in parallel. Boy, not great connections. These spade lugs not making great connection at all. Just a quick test. There you go, on, off. On, off. Okay, so we're good. Really should just rewire the whole thing. I might very well do that. When I was talking about the two coils on the bottom, here's the potted coils of the electromagnets. There are two of them, and they are separate. You could potentially control them separately. And you know what would be really handy is to add an XY table to this guy so that you could micro position. You lock the electromagnet down, and then you could position the part anywhere you want, the drill anywhere you wanted it within a short range. All you need is like a couple inch each direction, and you should be more than good to go. That would be a really nice addition. I suspect some better units have that. Now let's pop the C-clip, circlip off here. And I expect here's the O-rings that we were feeling. Oh yeah. So they did tempt some sort of lubricant in there, just not great. Oh, there's all kinds of debris in there too. I don't know if you can see this, but it looks like swarf from the cutting. Or no, it's not what I thought it was. It's shredded rubber instead. So the O-rings already started to shred. Matter of fact, it's damaged all over the place. So this thing's just going to start its life by leaking and then get worse. That's great. All right, so there are two inlet holes here in the middle of where this thing should sit, like here to here. These are what the O-rings ride on, and they're ground, so they did take a little bit of care. Interestingly enough, inside there's a spring. I'm not quite sure what that's for. There's also a circlip here. Let's pop that guy off and see what where we get. All right, let's see if we can get this circlip out. Okay, well, there's the spring-loaded part. I can feel that. So there's a washer, and there's an Allen screw pressed in the washer. And the rest of it is just wide open. That is really strange. So are they using this? I'm not quite sure how they're using this. Maybe when you put the cutter in far enough? No, I honestly don't know. Why do you think this whole assembly's in there? Why would you want a spring-loaded Allen screw in here? Because the coolant is not under pressure in any way, shape, or form. It drips down by gravity. So I'm not quite sure. Let's grab an annular cutter, see how deep that goes. So I don't see any way for fluid to go around the outside of the annular cutter because it would be sitting about like this. I don't really understand the spring-loaded part either. I'm not quite sure what its utility is. Maybe the annular cutter just slightly depresses it. Let's pop this guy back together real quick. And see if the annular cutter just slightly depresses this washer, in which case they might be using it as a really horrible valve design, but maybe that's what they're doing. Okay, so the circlip is pretty big. It might, because that's the first position, but that's not its final seating point here. There it is down there. So now it doesn't make contact at all. I got to tell you, I'm not sure what's that for. Maybe that's to control how quickly the fluid leaks around the outside of the Allen screw. I'm not sure. That's just a really weird design to me, because it's an Allen head bolt that they're pushing up against a standard, what looks like, I don't know, it might be a 12 millimeter or 10 millimeter washer. That's just really, really odd. Anyone have any ideas? I'm happy to hear them. Please leave them in the comments, because we could all learn something here. Because I'm not sure why they bothered. I mean, they wouldn't have bothered with the expense of the spring if it wasn't needed for something. I just can't tell what. What I'm thinking here is I might replace this whole assembly here with a slightly better one and see if I can improve the run out. But at first, what I'm going to try and do is I'm going to reseat this Morse taper, and maybe it's how the Morse taper is seated. It's ground, but pretty coarsely ground. So maybe it wasn't seated well. And there is no getting around this horrible lip, which I'm not sure why they did that either, why they relieved this inside, because that was actually an extra operation they had to perform. So I don't know, maybe that's to allow fluid around the outside, but I don't know what advantage that is, because these cutters won't allow the fluid around the outside, because they're going to be locked in like this. Like this right here. And it does not push down. The cutter does not reach the Allen screw in there, so I'm not sure what that's all about, the cap screw. Yeah, I really don't know. And you can see how sloppy this is. That's a couple thousand slop right there. And then on top of that, when you tighten this down, it's going to cant it because these screws are below where it's supported, so it's going to tend to shift it a little like this, which is probably why this thing is out of round so badly. And apparently this is not terribly hardened either, because you can see how it completely flattened off the edge of this guy with the removal tool, the Morse taper and removal tool. It dented the whole bottom of the Morse taper, so this isn't even hardened. That's really sad. Overall, my take on this magnetic drill press is that it was really inexpensive. It was less than a quarter, probably less than a fifth of some of the higher end models. It is very crudely put together, not designed for longevity. So you've got plated steel, mild steel dovetails that are screwed on, going to an aluminum extruded assembly that the motor's mounted on. So if you're using this long term, it's going to wear out pretty darn quickly. The run out on the included arbor is horrible. The motor's actually pretty decent. It's not awesome, but half a thousandth probably isn't bad considering. Cast aluminum body all the way around. I thought this was going to be plastic. This is cast aluminum where the motor sits. This is the reduction gearing in here. And surprisingly robust. Nice cast aluminum body. The electromagnet is very strong. It came miswired, which I had to fix. And the wiring is not a particularly well done job, so I'm probably going to spend a little more time and rewire this at work. Overall, I think for the money, comparing it directly to the $300 or so it cost, I'd probably give it a 3 out of 5, meaning it's adequate. It'll do the job. The run out here means it's going to wear out your very expensive annular cutters faster than normal because they're going to process, which means they're going to tend to rub on the side. That's definitely not great. And it will do crude holes. The drill chuck was optional, which I bought, and that's something I'd recommend getting. Some of the kits actually come with one. The one I got did not, so I would look for that. Yeah, I'm going to give it a 3 out of 5 just because it's utilitarian. It is definitely not well made in any way, shape, or form. The only surprising thing about it is the quality of the cast aluminum housing. Oh, and remember, I was talking about maybe the annular cutters that came with it do not push that Allen screw down, but guess what? The drill chuck that I bought aftermarket does push that Allen screw down when you seat this all the way. Look at that. So that must be acting as a very crude valve for the coolant. When you push this in, the coolant will flow. When it's out, the coolant won't flow. That is funky, to say the least. Well, that's all I have to say about this. You know, buy it knowing what you're getting going in. Don't think you're getting a quality tool. If not, if you do need that, then buy someone else's. Hugin, Milwaukee, DeWalt, probably anybody is going to be better. And that's pretty much all I have to say. Thanks for watching. Hope you find it interesting. I hope to see you next time.